What is the purpose of our subnet mask? In order to perform subnetting, we really need to understand what that subnet mask is all about. Well, the subnet mask is going to be used to identify the network portion of the IP address versus the host portion of the IP address. You see, every single IP address has two portions. We have the network, which identifies the network you live on, and we have the host portion, which identifies you, the device, on that particular network. And that's what makes IPv4 addressing unique. You can have a similar host portion amongst various devices as long as the network portion is not the exact same. So you can equate this to street names and street numbers. For example, if you live on Main Street and your house number is 5, you live on 5 Main Street. It's perfectly acceptable to have 5 Elm Street as well in that same city. But it would not be okay to have another 5 Main Street. So same idea here. We could have similar host portions amongst devices in different networks as long as that network ID is unique within your entire organization. So when we take our subnet mask and we analyze it in binary, we end up with ones and zeros. Ones and zeros in binary. So on the left-hand side here, you can see all these dotted decimal notations of subnet masks. But if you convert those to binary, the binary values have a very specific meaning. If you have a 1 in the subnet mask, that's going to indicate that you have a network bit there. It identifies the network portion. So ones represent the network portion. Zeros in the subnet mask represent the host portion. So if you analyze the address down at the bottom here, you see that we have 10.167.63.45. Based on the subnet mask of 255.000, which is right at the bottom, the very first 8 bits of the IP address identify the network portion. So, Main Street. And then all the rest of those zeros, the rest of the bits, the latter 24 bits, represent the device itself on that network portion. So 5 Main Street. 5 Main Street is an example. I want to analyze how we get our defaults. Because when I look at this chart here, I see Class A default, Class B default, Class C default. Well, let's analyze that before we look at that slide a little bit more. We have default subnet masks, which makes these addresses classful. When you're using a Class A address with its default subnet mask, or a Class B address with its default subnet mask, or a Class C address with its default subnet mask. So if I have an IP address that starts anywhere in the first octet from 1 to 126, I have a Class A address. So by default, its subnet mask is going to be 255.000. If I have a Class B address, which starts in the first octet with 128 to 199, then I have a default subnet mask of 255.255.0.0. And then if we have a Class C address, which is in the range from 192 to 223 in the very first octet, then we would have a default subnet mask of 255.255.255.0. And remember what I said, the subnet mask identifies the network portion and the host portion. So look at the Class A address. By default, the entire first octet is the network. The last 3 octets are the host. Now, how does that happen? It happens based on the subnet mask. So we analyze our subnet masks here in binary. You can see that the very first octet is made up of all ones, 8 ones, 8 ones. And ones represent the network portion, zeros represent the host portion. So you can see based on these default subnet masks, why we end up with a network portion of just the first octet and the host portion of the last 3. For class B, we end up with a network portion of the first 2 octets, followed by a host portion of the last 2 octets. And then for class C, we have the first 3 octets stretched out as the network ID, and then the last octet as the host portion. So it's all based on these 1s and 0s in binary.